Thank you for that introduction. Well, congratulations everyone. You have finally made it to the last talk of DjangoCon. So yeah, I know. You all need to prepare for after party, but yeah, we'll quickly wrap this up. So yeah, Django admin at scale. Let's start. First, let's talk about Django admin, right? Because it's basically a dream, right? Because much, without doing anything, you get to so much, right? Like built-in CRUD operations without writing any code, just initialize your models, and form validation and generation, that too without anything, and authentication and permissions out of the box. That's really cool, right? And also you can easily customize it with a couple of lines of code. Yeah, basically a dream. The I believe the best thing since sliced bread, right, for rapid development. Now, let's talk about a real story. Like, to be honest, is the reason I'm here. So last year I was consulting a streaming company where we had a critical table called notification log. This table tracked email templates, like when emails were opened, clicked, campaign performance data, and user engagement metrics. It was very critical for the business because our product and marketing team relied on the data, because this data helped to identify what our user likes or dislikes, so that upcoming campaigns can be designed basis on that actually. But one day a disaster struck. So have you been trying to open a page and waiting, like just to some data, some metrics, but after so long you get this, right? So yeah, so that's what our product manager saw. So our product manager opens admin to check the performance of latest campaigns that were recently deployed. But after endless loading, what she sees is the good old, I think, sorry. Yeah, the good old 504 error. So the reality check here is when our database grows, so the Django admin can become very slow. But and on Slack, all I could hear is that we need these pages working again, right? And they need to be fast. So the business impact, like because of these 504s, or the managers were not able to see the metrics. They were not able to verify campaign performance. Marketing decisions were delayed. New features were put on hold while we fixed the admin, made it fast. And also the team credibility was damaged because we had legacy systems already, which was working without issues, and but with modern frameworks and this latest framework, we were seeing 5 hours, right? That should not be the case, right? I mean, Django is fast, right? I mean, we can definitely scale, right? So the turnaround. So we implemented after to and fro, complete couple of techniques, or like what to do and what's not to do in our code base, which I'll show you today. And so the before, what was happening is timeout errors like greater than 10 seconds, basically 5 hours, frustrating teams were not able to see the data, and it also impacted business. But after a couple of our techniques, or after implementing these things, so the response dropped down to less than 200 milliseconds. But I know the title says microseconds, but yeah, you all were clickbaited, so sorry. But yeah, so after our implementations, products managers were happy and able to quickly see the data and act on that. Then they were able to take data-driven marketing decisions actually. So yeah, now let's talk about today's journey. So like what we'll be going through. So first will be diagnosis, like how to identify common performance bottlenecks, like what can be minor issues or bottlenecks that you can easily identify. Then we'll talk about solutions like battle, what we have implemented and what we have changed. So that techniques I'll be showing you. And then maintenance, like how we can keep these performance over time, like the code base grows and your database grows. So that. Now let's talk about like diagnosis, like what makes our Django admin slow. I believe you all have probably faced this by now, I guess, the simple n plus one query problem, right? For example, this order admin, we are just showing the ID, order ID, total and status, and the customer name here, right? But behind the scenes, what it will do is, it will make one query to fetch orders, but n number of queries to fetch related customer for each order, right? So basically n plus one queries. And when you go use Django debug toolbar, you'll see something like that, right? On the top, you'll see some meta queries and the count query, which is from default paginator. But in the drop down, you'll see lots of this customer queries, which is happening because of our customer name, right? So next one will be inefficient filtering, right? So we can have lots of filters, right, in our models and tables. For example, in a product admin, we have something like this: category, tags, and stock, right? But when your database grows, right, it can contain millions of records, right? So for this filters will basically make full table scans, and if you have multiple filters, that you see where I'm going. So we'll talk more about this at the end, because this is the main reason I'm presenting here, because the filters were the main reason. And another one is memory intensive admin actions, right? Just like for example, we need to mark product active, featured or not. So we can, something like that, we just loop over the query set and product is just set it true and save it. But let's say we have selected lots of objects at a single time. It can lead to out of memory errors with thousands of. So, and individual saves, so n queries. So that is one common bottleneck. Next will be change forms, right? For example, in product, we can have different foreign keys, which can contain thousands of options for like categories, tags related to products, like, and many-to-many keys as well. So Django will load all options for each field, like all categories could be thousands, right? And all tags could be tens of thousands, and other related products. So yeah, that can lead to very slow page loading, and it will basically lead to 5 core. Next, so these were the common bottlenecks you'll probably see. Now, how to diagnose your own admin, right? Like these were some issues which I faced. There were some others, but yeah, those were the very common. So how will you diagnose? So first thing is officially Django debug toolbar. Please use that. If you are not using, please do use that. It really helps a lot. You have seen the screenshot before, that how the queries will be visible from that screenshot. Then you can write your loggers that basically logs your database query logs, like how much time is taking, what is happening behind the scenes. You can use those. And Django Silk Profiler is also a very nice tool. If you are not using, please do check it out. Then you can utilize queryset.explain, like index is being used or not, what's going in the query. So you can utilize that as well. Other than that, the different tools like New Relic, Datadog, and Sentry APM is very nice tool. You can probably utilize that to monitor. Let's come to solutions, like how we started to improve our Django admin to make it a bit snappy rather than throwing 5 cores. So let's talk about the n plus 1 problem, right? It can be easily solved by strategic related field loading. For example, we are here showing the ID, customer details, total, and status. So before using that list selected, we were causing n plus 1 queries. Now if we just use that, and it will just one query, it basically create a join in SQL and it will fetch the customer with the orders. You can also write custom display meta just like we are doing here. If you have any custom thing you want to appear on that admin page, you can utilize this, something like that. Also, you can use preloaded annotations, which basically helpful for calculated fields. Like you don't want to do every time to for every object. You can just on query set level, you can just annotate this, and it will just utilize that. Next is pagination. Before I talk about this, in DjangoCon 2022, Tarun gave a very nice talk which covered different pagination techniques. This can be a very good starting point for implementing custom pagination. So if you have not checked it out, please do. So here, let's just say we have lots of records in our table, for example. By default, a list per page is 100. So if let's just say we have millions of records, like 100 is very small, right? We can probably increase it. So a better approach is, by default, it uses offset limit pagination. To make it optimal, we could use key set pagination, or some might of you know as this cursor pagination, I believe. So this is a custom implementation which I'll be showing you, like how we can utilize. So it basically uses rather than using limit offset, we use the primary key to fetch the ID from the previous page and use that ID to filter the records for the current page, right? So it will basically perform better to our traditional limit offset pagination on a larger data sets. With custom pagination like this, we can easily paginate through millions of records. Here we, as I told, like using the last ID from the previous page and then filters the query set. Major benefits in this approach are that filter can use the index, right? Index directly, because usually we'll be filtering out the primary key, right? So already indexed, so it just helps. Whereas the limit offset pagination would need to scan and discard the earlier rows first, and then we'll fetch others. So let's, this brings us to optimize admin actions, right? Previously we were looping around just to, save our products, just to market feature, but we can utilize the bulk operations without loading any object, like just use the query set update. It will basically update all the records in a single query. Super efficient. For simple operations, rather than using loop, very efficient. But now you all can say, like, what about the complex operations, right? We need to do something before saving the object, right? And now that takes us to batch processing. So what we are doing here, we are basically creating batches so that it doesn't take lots of memory at a single time, so that basically leads to OM. So just create a batch of, let's just say, for example, 1,000 objects or 500. It's basically on your, like, how your server can handle. Create a batch like this and just process it batch wise. It will be very efficient rather than by going or looping over. So it will basically help you. Now, change forms. So for foreign keys, when you have multiple options or categories, when you load that page, it will basically start to time out, because let's just say a foreign key has thousands of records, right? So it will basically take some time. So you can replace it with raw ID fields. It basically just show you the ID of that object, and you can just go there, and it will take you. So it will save you some time. For many-to-many, we have filter horizontal. It will basically help you to load many-to-many keys, records easily without taking much time. Now you can force your query set size as well using the overriding get form. Here we are. I'm for related products. I'm putting in a limit for how much products I need to load, so that you can also do. For expensive field, like which need some processing. So you can utilize this field sys, which collapses classes to defer loading expensive form sections. So it basically helps you save some time. Now, interesting stuff, targeted caching. So anyone here have used Django cache ops? If not, that's great. If not, please do check it out. I highly recommend it. Very nice library, handles most of the things automatically, like cache invalidation, query state invalidation, everything. So, and it is very stable and production ready. So please do check it out. So here's an example of custom model admin which we can utilize. Here we are just caching our query set. For the timestamp we can provide, like how timestamp will be, the timeout will depend on how frequently our data is being changed. You can, for your, as per your need, you can put anything like that. But the cached as is provided by cache ops. Basically, it will create a query set caching in your whatever cache you are using, Memcache, Redis, or it works with all of those. So it basically caches your query set, and it will be utilizing every time you fetch it. Now, how we can use this? So just inherit from our cache ops model admin and just set your timeout for products, and it will basically start using your cache, right, for fetching records. Next, list filter optimization, right? So for standard, it basically loads for every request. Like it will basically query your table to fetch the categories. But what we can use is override this admin simple list filter and just override the lookups method. And by caching, you can just limit our options by using a query set, and it will basically use the caching option. So it will improve your list filter optimizations. And next is, when everything is not working for you, then probably you can utilize raw SQL, but I don't highly recommend it. But use sparingly with consideration, because soon your code will contain more SQL and less Python. So yeah, I have seen it. So yeah. So that were some solutions that we have implemented and improved our performance of our admin pages. Now, maintenance, like how we can keep these performance gains over time, right? So monitoring strategy, it basically depends on your use case, like how you're growing and how your code base is growing. But these are some techniques which I have seen or I have implemented. Basically, you can create your custom middleware to track admin performance, set up alerts as well, like for slow, let's just say it's taking more than 200 milliseconds. So you can just log it somewhere and you can just work on that, like what it's why it is taking so much time. Then you can also have regular profiling sessions. We used to have bi-weekly sessions for our API, like what last 2 weeks, why there is a spike. So then we started to talk also about like why this Django page is spike, what was the reason, like why this went slow. So we started talking about that as well in our sessions. Then last thing is you can also use monitor your index uses, because it can also become slow when it grows, right? So a sample performance middleware can be something like this. You basically in your middleware, you can just basically logs your, like it went below the threshold. So you can just log it and see what is going on. You can just improve it later on. Like also you can do performance testing as well. Add admin specific performance tests. Try to measure with realistic data volumes. I know it's a bit difficult to replicate your production load on local, but it's manageable somehow. Also, you can simulate real user interactions, not just page loads. So a simple performance test can look like this. Like we created 10,000 test records just to test like how much time it will take. So it basically depends on your needs. So you can just utilize that. So real world example, like what I or my team did. So this is what my log admin looked like. So it has, as you can see, it has 6 filters. We for pagination we were already using no count paginator, so no count query. So yeah, and I believe we were already using list selected, but still it was throwing 5 or 4. So after uh, digging, checking out like what is taking some time using debug toolbar. So the major problem was the lookups QS here, right? It was, I believe, at that point of time, it was maybe overly optimized, or it might have been assumed that the categories which we are fetching might be dynamic at some point of time, but the values were static and came from constants, right? And they were defined by analytics team, so that they can easily query. So they these categories can be returned without utilizing DB, right? We can just return these constant without DB usage. So what we did something like this. Let's just say we had categories like this. So we just created this value pairs and just returned it in the lookups rather than making query for that, right? So it basically takes us back to the good old principle. KISS, keep it simple, stupid, right? You don't need to query if these are in our constant, right? So sometimes we try to make things complex, which may not be required, but sometimes it's required. So basically on your need. So the next thing what we did was started utilizing the only and defer fields. So we did since it was a big table, we needed lots of table data, but we knew that we don't need this data, so we utilized the deferred fields, or defer, so that it can basically just remove these fields from the query set. So it improved the performance a lot. Also, we are using here, if you can see the dot cache here, it's coming from Django cache ops. So we can just utilize like what ops like get, count, and you can define your method what I'm forgetting the term, but in ops you can just like dot get, count. You can define that, and it will basically cache that. And obviously timeout will use that for validation and everything. So the key takeaways was in my local I was not able to replicate like why this is happening. So always try to diagnose with real data so what I did was installed Django debug toolbar on my QA environment. The QA team was not very happy, but yeah, I had to do it. And also, like next thing is think about query counts, not just speed, because major of the as in previous talks I've seen that major of the slowness comes from database. So that too. So when optimizing, try to use built-in tools first, like select it only, defer, etc. It really helps a lot because Django is supposed to be fast, right? Then use cache strategically, because in read-heavy applications, the data might not be changing that much. Also, the last thing is monitor and maintain performance. So, yeah, I believe. Thanks for listening. That is it.
Thank you very much, and congratulations on making your product manager happy. But in your case, and also in many other cases, I think you only run into these performance problems after they already hit production. Do you have any tips for us on like preventing common mistakes during, for instance, code review?
Just like I told, like try to write, test performance related tests so that you have an idea like how much load your code can take at this point of time. So probably adding performance related tests will help you. Also that admin that middleware I showed, it basically help you to identify problems earlier. So that might be useful for you.
Yes, thanks.
Thank you.
We have one question online. Will this also improve CRUD query set operations that are carried out in the front end or not in the admin? For example, what we are using DRF?
Can you please repeat?
Using DRF.
Using the
Okay, I'll repeat the question. Will this also improve CRUD query set operations that are carried out in the front end and not in the admin? For example, what if we are using DRF?
Yes, I believe using select-rated only will definitely improve your API performance. And yes, definitely.
Thank you.
Thank you.
Yeah, thank you for the talk and the overview of cache ops. And I was wondering if there are any other caching strategies that you tried and experimented with before arriving at this that you could talk about.
Previously, we were using normal Redis caching, so it had lots of problem like invalidation and everything. So that's when we got to know about this library, that it handles automatically most of the things for us. Right? It caches the query set directly, so I don't need to convert it to a list and string format. So that it's just add some more time. So that's why we got to know that try to use Django cache ops. It will basically help us sometime.
Thanks.
No more question. So then, thank you again for your talk.
Thank you for listening. Thank you.